This video will give examples with exponential growth and decay. There is a population of unicorns in a magical forest. Every year, werewolves eat 6% of them. How many unicorns will there be in 15 years if there are 500 to begin with? Assume no baby unicorns are born. So here we have something where y is decreasing by a specific rate each time step. So that means we'll use this formula to model our population. Now we know that A equals 500 because that's how many unicorns we start out with. And R equals 0.06, so 1 minus 0.06 to the power of t, or 500 times 0.94 to the power of t. If we want to know how many unicorns in 15 years, all we have to do is plug in t equals 15, so y equals 500 times 0.94 to the 15th. And we find out that there are about 198 unicorns remaining. It makes us really sad that all of these unicorns are dying, so we're going to try to convince the werewolves to eat less. What percentage of the unicorns can the werewolves eat each year if we want to have at least 300 in 15 years? So again, we're going to use this formula, 1 minus r to the t. A is still equal to 500, and now what we're trying to do is solve for r. So we can write y equals 500 times 1 minus r to the t. And we're given that when t equals 15, we want to have y 500 times 1 minus r to the 15th. We want to have that equal to 300. So now we can take this equation and solve for r. So that means we have 1 minus r to the 15th equals 0.6. So now we can take the 15th root of both sides, and that gives us that 1 minus r is about 0.9665, means r is about 0.033. So that means that we have to convince the werewolves to decrease their habits from eating 6% to eating only 3.3% of our unicorn population. The half-life of uranium is 72 years. Find the value of K in the formula y equals n times e to the kt. So we know that if n is the initial value, after 72 years, y equals 2n. So we can plug this in to our equation. 2n equals n e to 72k. Now we can divide by n on both sides. 2 equals e to the power of 72k. We can take the natural log of both sides so that we end up with ln of 2 equals 72k, or k equals the ln of 2 over 72. So k equals about 0.0096. Now our unicorns have started breeding. We have two populations of unicorns, one in Narnia and one in the Forbidden Forest, and their populations are given. When will the two places have equal populations? They'll have equal populations when the y's are equal, so 120 e to the 0.04t will equal 90 e to the 0.08t. Now we can divide by 90 times e to the 0.04t on both sides. So we have things canceling out. We end up with over here 4/3 equals e to the 0.08t minus 0.04t, because when you divide exponents you can change them into subtraction. And so that just simplifies to e to the 0.04t. Now we can take the natural log of both sides, so ln of 4/3 equals 0.04t. Using a calculator, we evaluate this to be equal to 0.29. So that means that t is equal to 0.29 divided by 0.04, or t equals 7.192. Justin Bieber gets a new haircut and 1,000 teenage girls find out. They text their friends, so the number of people who know increases 30% each second. How long before every teenage girl in the U.S., which is about 10 million people, knows? So this can be modeled with y equals a times 1 plus r to the power of t. So we have that a equals 1,000 and r equals 0.3. So y equals 1,000 times 1.3 to the power of t. And we want to know how long before y equals 10 million. So we'll set that equal to 1,000 times 1.3 to the t. Divide by 1,000 on both sides. So 1,000 equals 1.3 to the t. We can take the log of both sides. So log then we can bring down our power using the power rule. So this would equal t times log of 1.3. So that gives us t equals log 10,000 over log 1.3, which is equal to about 35.1. So in about 35.1 seconds, every teenage girl in the United States will know about Justin Bieber's new haircut.